The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. This is Jim Bentley with Hartland Southwest. We're here for the webinar on best practices for moving air in harsh environment applications. I'm here along with Ray Faries and David Luna from Orion Fans. David is the Vice President of Marketing. Ray is the Technical Product Manager. So before we get started, I just want to point out a couple of things. First, everyone is muted, so you will not be able to unmute yourself to ask a question. If you have a question, please put it into chat. I'll be watching those questions as they come in, and we will answer them either at the end, or if it applies to what's being talked about at that moment, we'll in that section answer that question. So let's go ahead and get started. So harsh environment AC fans, DC fans, and accessories like specialty filters are designed to protect against dust, moisture, salt fog, salt spray, temperature changes, humidity, and more. With more capabilities available than ever before, including higher temperature ranges, speed controls, and tachometer output signals, to name a few, OEMs are using fans as a means of providing increased functionality to maximize energy efficiency and decrease overall cost of ownership. Ray and David will be discussing today's trends and best practices for moving air in harsh environment applications. So let's start with David and Ray. What are some of the general challenges designers face regarding thermal issues?
Well, the thermal issues in general, not just in harsh environments, one of the biggest ones is cabinet density. In this day and age, we're starting to see, they're putting more and more products into smaller packages, and the last thing they think about is the heat, because you're generating heat, and everything generates heat. The density, the airflow restrictions, that's the real problem. Is that anything you put in the airstream, whether the intake of the airstream or the exhaust of the airstream, reduces the efficiency of the fan. You got to have space for the fan in the cabinet. And cabinets are very dense. That's a problem. And that fan needs room to move. The rule of thumb we use is that you should have at least the diameter of the fan away from the fan open, because there's a great big hole in the air where the impeller sits. Heat's the enemy. Heat's the enemy of the electronics. Heat's the enemy of the fan. Fans do not cool things. Fans move air. That's all they do. They cannot cool anything. All they can do is move ambient air. So hot air is hard on the fan too, as all other harsh environments are hard on the fan. Fan failures tend, over time, they slow down or stop, which in harsh applications can be a real problem. Most fan failures are just a stop. They don't tend to slow down and just get slower and slower. Usually, if that happens, it happens very quickly. The failure mode on fans most of the time is the bearings. That is the weakest point in the system, and that's basically what sets the L10 life we use for them. Harsh environments, because of that, we can also give monitoring for the fans. The DC fans especially, we can put tachometers on them. We can put alarm outputs on them so that the customer can see in his cabinet if he has an issue remotely without having to be right there in case a fan, when it goes away. Because we make fans, but as I hate to say it, fans do fail. That's just part of life. And the harsher the environment, the shorter the lifetime can be on the fan.
Yeah, and I think in this image we're showing that MRI or CT machine where pretty much most of these fans, just because of the nature of the application, a lot of them are all metal fans, but some of them for the, let's say, non-harsh environment can be plastic blade types. But it's something like this where you might even have EMI or electrostatic or whatever. Something could happen where you have to have some kind of harsh environment or some kind of need to have that fan be a little bit better than your normal standard off-the-shelf fan.
Yeah, the harsh environments just bring another set of challenges, as I like to, as the deal says. It brings another set of challenges, which is a nice word for problems.
So let's stick with harsh environment. So what are common harsh environment conditions that cooling solutions must overcome?
Yeah, Well, you have indoor and outdoor exposures. Water, rain, spray, salt spray, snow, ice, mud, dust. People don't think about dust being a harsh environment. Dust is a very harsh environment. That can be a lot of problem. We can do salt fog up to a GR 487. So any of you that are familiar with the telecom industry, that's a Belcore spec, GR 487. It is a really, really hard spec to pass. It's 30 days in a salt chamber. You're allowed to rinse the fan out with salt water in case you have so much salt built up that the fan will no longer turn. That's how hard it is. We can't do all of our fans to GR 487 just because of the way their structure is, and because we have to do some special stuff on the internals. But we can do several of them, and we have fans in lots of telecom applications right now for the GR 487. Corrosive agents. These days we're seeing a lot of people using ozone for sterilization, for cleaning air, for drying organics. We'll use that term. People are pumping ozone into things. Ozone is very corrosive. It'll kill a fan in about a week, depending on the concentration of the ozone. So we have a coating that we can kind of protect the fan from the ozone. Extreme temperatures. Fans don't like to be real hot. Our highest rated fan is 100 degrees C. And in DC, it's pretty much everybody's at 70 degrees C unless you go up to some military grade stuff, in which case they get very, very expensive. AC, we can get up to about 100 degrees C, which is hot. I mean, that's very warm. You do have degradation of your life as the temperature goes up for the fan. So as you get hotter and hotter, your life expectancy of your fan goes down substantially. If we spec a fan an L10, which says that 10% of the fans are out of spec, and we say it's 60,000 hours at 40 degrees C. At 50 degrees C, that's now 30,000 hours. And at 60 degrees C, that's now 15,000 hours. So it's very, very rapid decline in life expectancies of the fan. But conversely, if you're going down in temperature, it gets better. So if you go from 40 down to 30, you double your life expectancy. You're up to 120,000 hours. Most fans are only spec'd to run down to about 20 degrees, negative 20 degrees. I always say, why do you want your fan running at negative 40 degrees when people ask me that? And most of them don't, but that's the spec they have to live with. Some of which we can get away with, some we can't because of the lubricant and the bearings. Dust, dirt, and sand. Those are very hard because some of the sands, depending on where they are, can be quite conductive, and that can be a problem. One of the problems we had a customer was building car washes in Saudi Arabia, and the fans he couldn't keep the fans alive. So we built him an IP55 fan and made the problem go away. As far as I know, we had 0 failures since we switched him over to an IP55 version fan. Shock and vibration, another harsh environment. Constant G-forces. Fans really don't like sharp shocks. It is a delicate electronic instrument. People don't think of a fan of that, and I always laugh and say, "Hey, we sell rocks. We sell delicate rocks." There's a set of bearings inside a fan. Most of what we sell are dual ball bearings, which means there's a cage ball bearing on each side of the fan. And if you drop that fan, you can knock the bearings out of alignment. And if you knock it out of alignment, then the fan doesn't last very long. And constant G-forces, just imagine, take your household fan and spin it around in circles, and how it's not going to work for a real long time. You get up around, 30 or 40 Gs, the fan's just probably not going to continue to work. But that's not just us. That's the whole world of fans. That's just kind of what you run into. Shock and vibration. Our fans are designed to withstand a fall onto a wooden board from 24 inches. Most of them handle that without any problem. If we have a rule in our warehouse, if somebody drops a fan onto the floor from the tabletop, it goes in the trash. We don't even think about doing anything. We just throw it straight in the trash. And we suggest that any customers that, you drop one, just throw it away. You'll save yourself a lot of grief in the long run. we're talking about the harsh environment applications. There's hundreds of applications. Telecom stuff, air conditioners, heat exchangers on outside of the buildings. We talked about car washes, pool pumps. We have put fans into pond pumps, so they're sitting out because the pond pump's sitting outside, making the fountain, so all the people in the apartment complex are happy. But those are sitting outside. Anything hanging under a truck or a trailer that may be exposed to road splash or road wash. Anything on a ship, anything near the ocean, almost anywhere near the ocean, where you have a lot of salt in the air that can cause issues. So, the applications, these days, we're building a lot of stuff for LED lighting that's outside. Well, you put a light on a power pole, it's going to be exposed to the rain, so it has to be able to withstand rain, the rain forces. There's lots of applications.
Back to what you said earlier. If you remember, though, we do have now a DC fan that goes up to 100 degrees C on one of our new series that we're introducing, but it's an all metal, obviously, fan, all metal frame, all metal blade, but it's a DC that we can get to 100 degrees C, which is kind of a specialty fan. And back to the dust you mentioned about being conducive, we are conductive. We actually do have that IP68 with ATEX fans and our EC fans that are good for that, right? For explosion proof or something, because dust can be
different kind of dust,
I guess.
Yeah, if you're talking about like dust in a silo, that kind of thing, absolutely. Where it can be an explosive environment. Yeah, and I don't talk about the 100 degree C DC fan because I hadn't seen it yet.
We've got one.
I've seen the release on it, but till I get to touch and play with them, I try to not talk about it too much. Okay.
All right, Ray, anything else on these applications for harsh environment?
Well, say as the screen shows here, where you have particulates, heavy mechanical. We do a lot of stuff in heavy machinery. We have a lot of, but that's kind of like in the truck world, but not necessarily a truck. Refrigeration panels, downhole. We do some downhole. It's not a big business for us, but the pulp and construction business is very big business. Refrigeration and food processing is real big business for us. Okay.
All right. So what are the types of fans that can be specified for harsh environment applications?
Well, we make AC and DC. Our ACs, we can make almost any of our DC fans. We can make IP55 without a problem at all. You tell us that's what you want. I've made one as small as 25 millimeters that went into a lamp on a bicycle headlight. Is a 25 millimeter fan. So we can make those to IP55 without a problem. IP55 is water jets in all directions, which is all that most people require. And the IP55 is also will give you the corrosion resistance against the ozone. So we've had very good luck with that. Most of the really harsh environment fans are metal framed with plastic impellers. We do have metal frames with metal impellers. It's not necessarily absolute that you have to have it, but because of the environment we tend to. The frames are not going to break from water or what have you, but the metal frame gives you a little better heat transfer, and that's part of what that's all about. We can do up to IP69K, which IP69K is washed down for medical and food service. That's what it was done for. Most fans have a metal blade or a metal frame and a plastic impeller. We do have some with metal impellers. Excuse me. The IP fans, what IP means is ingress protection. That's the level of protection, and that's an international standard that's done. International standard. Redundant there. The first character tells us what the level is of dust prevention. So we got 1 to, maybe you can pop it up for me. There you go. Thank you. 1 to 6 for dust height. The second level one is really the most critical for most people. The ingress protection of moisture. 0, which is the standard fan that everybody builds, that says, don't get it wet. That's kind of what it is. And then it works its way up. We do it some that are up to a 2, which is, which is basically just a conformal coating. It's not real good. What we try to do is IP55 and up. IP55 is water jets all directions. IP56 is a stronger water jet. IP67 and 68 are immersed. And I've told people, if your fan is underwater, you probably have a bigger problem than the fan being underwater and not working. My favorite deal is the customer was building lights to go on light poles in parking lots, 40 feet in the air. He were demanding that they be IP68. I said, if that fan is underwater at 40 feet in the air, we don't care that the fan don't work. It's just kind of it. But people get specs, and we understand they get somebody writes up a spec, and everybody's hung up right now. Everybody wants everything to be IP67, 68. It's an overkill for probably 95% of the applications. 55 probably takes care of most all of them, but we can do all these, and we're moving forward every day with adding new series, adding some of it. We have to change the frames so we can add the deal. Due to the immersion in the 67, 68, 69, we have to pot the motor. So we have to completely encapsulate the motor to be able to withstand the rigors of basically being underwater or having caustic chemicals sprayed on the motors. Excuse me. Sorry about that. But anyhow, just so everybody understands when somebody talks about IP, that's ingress protection. What's the fan going to live with that gets into it? It's not necessarily keeping it out of the fan, but it's what the fan can live with. Because you can't keep things out of the fan just because of what it does. The fan has to be exposed to outside air.
All right. So
going back to what we talked about on the different applications, all the way through the louvered fan, we can provide a harsh environment type fan in any of those applications, or even in the louvered filter fan, because we can add an IP68, IP55, or a salt fog or whatever in an AC or DC, and make it a complete kit if we wanted to.
Yep. The problem with part of that is when you poke a hole in the side of a cabinet, you lose your integrity of your cabinet. The fan has to have a hole in the side of the cabinet or it cannot cool anything. If it cannot bring outside air in, it cannot cool the cabinet. Otherwise, you built a convection oven. All you're doing is stirring hot air. So people want an IP68 cabinet. Well, realistically, that's absolutely not physically possible because you've poked a hole in it, and when you have a hole in it, water can get in. Our fan will live in that water getting in, but your cabinet's no longer going to be IP. It would be IP68 rated because it's got a hole.
all right. So you mentioned you talked about IP69K. So let's talk about food and beverage applications. What are some of the additional fan requirements when food safety is involved?
Yeah, that food safety. I mean, you get to extreme temperatures. Sub-freezing for your freezers, and some of the freezers are really, really cold. Up to convection ovens, which get very, very hot. Most Class A fans or AC fans are Class B rated, which has a 130 degrees C insulation in it. We can do some Class F to 155 C, but we don't rate them that high because you have durations, because you have an electric motor in there that's generating heat, because the fan itself is generating heat. So you can't say, oh, my Class B fan can run at 130 C, because that's not true. It can probably closer to about 70 or 80 C is about the max it can get to. You get up to the 155 C, you buy yourself another 20 or 25 degrees. That's how we can do some of our 100 degree stuff. All DC fans are, the installation on them is Class A. It's 105 degrees C installation for all standard. Just as David's reminded, we now have 100 degrees C one. It'll have a different winding in it. That's just the winding, the class installation of the windings and the wires, then where it tends to break down. The electronics on the DC fan, on standard DC fans, is rated at 70 because the electronics are in there. They're all commercial grade electronics, which are rated to 80 degrees C. Then once you derate them, now your fan's down to 70 degrees C. Will they work above that? Yeah, but not for a long, long time. If you're trying to run something, if you have an application where you need to turn a fan on for a few minutes and have it turned back off, and it's not in a heat stream, your DC fan will probably be okay. But if you're trying to run it, for long periods of time at 80 or 85 degrees C, the fan's really not going to last very long. Just unfortunately. Let's say temperature condition. You have to include the heat rise in the motor, because it is an electric motor. It's a very small electric motor, but it's an electric motor. Food safety, they require the wash down. The IP69K is what that is. That's a high temperature wash. So you have really hot water, potentially with chemicals in it, to do the wash down. And the IP69K was generated for the food service industry, and we made one to go meet the IP69K rating. That's a pretty tough rating to get to too. It was actually developed for vehicles, for extensive cleaning, garbage trucks, cement mixers, agricultural vehicles. Medical picked up on that, marine picked up on that, oil and gas picked up on that, and the wastewater guys picked up on that, because they all kind of have some of the similar problems where they're having to clean things up. And when you got to clean things up, you're typically using high pressure water, and a lot of times that water is hot. And again, maybe using some kind of a caustic chemical in there to help do the clean.
Yeah, the other nice feature on those two and the IP69K is we've seen industries with DC fans only, but not really any with AC. We've got AC and DC available with an IP69K rating.
Yeah, our product breadth is getting very, very big in the harsh environment world. We can get to most applications now.
So you mentioned outdoor applications previously. What special fan requirements do you see in outdoor applications?
Yeah, the biggest one there is weather, rain, and in coastal areas where you have a lot of salt in the air, in places where you have a lot of snow, where they're putting salt on the roads, and then that gets splashed on things. Salt and water are a problem. The weather generates that problem. You have some animal interference. You can have critters coming up, sticking their if anybody has raccoons around, they want to stick their little paws into everything that's around, and that's a problem. So you gotta have something to keep external stuff from coming in, which includes little kids' fingers, which they tend to stick their fingers in every little hole they can get their hands in too. The high static pressures you get from trying to seal up a kiosk or a pump controller, whatever. So you want as few. Most customers want as few holes in their cabinet as they can get. And when they do that, they increase the static pressure that the fans. So the fans having to work very hard. We make some very high static pressure fans to help overcome that, but you have to have an inlet and you have to have an exhaust hole in your cabinet. And when you put a filter in front of it or on the exhaust on either side, it's really not. It's a little redundant to be putting filters on the exhaust side since you're pressurizing the cabinet anyway. So really, dust shouldn't be able to get in there. But as your filter reduces your airflow, it reduces because it creates a pressure variance in there, and excuse me, and your filter is going to get dirty if it's doing its job. And as it gets dirtier and dirtier, this pressure drop, the airflow drop through the filter can drop significantly, and it can drop. It can potentially drop all the way to zero. That can cause an issue. Outdoors you got kiosks, you got vending machines, you got pump controllers, you got electric vehicles charging stations, which is really big right now. Telecom enclosures, everybody's seen those stainless steel cabinets sitting on the side of on the corners of roads. Lighting controls for traffic light controls. Again, those big silver cabinets sitting on every street corner where there's a traffic light. Those all have fans in them, and they're subject to some pretty harsh environments out there sitting on the side of the street. Heat being a big problem because those big metal cabinets get, I'm in Dallas, they get hot. They'll open them up. One of my customers is opening, every time he opened it up, he had LCD displays in there, and they'd all be completely black till he left it set and open for a few minutes so they could cool down enough so they could come back to life. So a fan's kind of a necessary evil in those applications. The outside stuff, if you cannot put a fan in it, you'd rather not, but a lot of stuff, especially anything coming to Dallas and Arizona, it's got to have it. Got to have it.
So are you seeing filters used often in harsh environment applications?
Absolutely, because anything outside or even in like a machine shop where you have a lot of particulates in the air, we have specialty filters and we have delivered filter fan kits. We make 3 different versions of those that have removable media in them. The specialty filters actually go into the delivered filter kit. They can be used standalone, but they're actually made to fit inside that. So you take the styrene foam that's in there out, and you put one of these filters in there for various levels of protection. Again, but everything you filter reduces your airflow. A standard louvered filter with just a standard filter in it is about a 40% drop in airflow just coming through the filter. That's pretty substantial. And it varies a little bit from fan to fan and application to application. But that's a lot of airflow when you're losing. But you want to keep things out. The louvered fan guard is made to keep, so the rain's coming down, the rain runs off the front of it. The filter media helps keep a lot of the moisture out. The rated IP54, they'll meet the NEMA 12. They are not NEMA 12 rated at this time. We're working on getting the NEMA rating. There being a little bit of a problem on that, but it's going to happen. But anything that's going to be out in the weather probably should have a filter on it of some kind, and for certain a finger guard to keep people's fingers out of it, because fans can't hurt you. And it's a spinning blade that's probably spinning somewhere between 1,500 and 4,000, 5,000 up to 10,000 RPM, which so it'll cut the end of a finger off if you stick your finger in one run at full speed.
And then trying to make it easy access is important because the filters, will last. Luckily, the specialty ones we have, you can actually wash down and reuse, but some of the other filters are almost like throwaway. You almost have to take them and then replace them on a periodic basis.
Yeah, and like I said, we talk about 3 different. We have our LFG, which is just a snap-on front. We have the LFG-H, which has a hinge front. You can see the picture there on the bottom right, but it's on the bottom left, but on the right side, that's a hinge one. And we make an LFG-S, which the guard actually just slides down. And all those are done just to be able to change the media out, because you're going to, if you're putting a filter in, that means you're going to probably have to change the media out at some point. A lot of people just buy it and throw away the white foam filter that's in there, but it can be washed out. Just depends on how much time you want to spend on on whether you want to mess with a $1 filter trying to clean it up or not, or just throw it away and buy another one. And any fan can be put with I won't say any fan. Almost any fan can be paired with the LFGs, any of the LFGs. They have multiple mounting holes on them, so we can
from 80 millimeter to 280 millimeter.
Yeah,
don't go too small because of the filters we can't make them small enough.
Yeah.
All right. So what special cooling requirements are there for explosive environments?
Yeah, that's a whole nother world. ATEX Zone 2. We are a ATEX Zone 2 application for our ATEX fan. We have a fairly small offering of that. It's 3 sizes currently. They are full ATEX rated. They are EC fans, which means they're electronically commutated. They're very efficient, and they have the ATEX search. That's the big thing with them. ATEX means it's spark proof. That it's not. It should not cause an explosion. And if you have a gas leak or a dust environment or what have you, it's not made. Zone 2 is not made to be in there all the time. It's not made to be like in a gas chamber all the time. But it's something that it could have gas leak into it, like at a at an oil field application where you might have a short-term gas leak or what have you. They're made for that. That's what the Zone 2 does. Anything that's got a lot of very, very fine dust particles is what requires the ATEX. Petrochemical guys, control panels, pulp, variable speed controls, lots of places out there. But it is we have 120 millimeter, 172 millimeter, and a 254 millimeter versions.
Well, we have a 60. The 254, we're still waiting for the certification by next month because UL's been very slow.
Right. Okay. We do have a 60 millimeter. That's right. I forgot we had a 60 millimeter. The 254 is hung up in some UL testing right now. So, but it's going to be there. It'll be there sooner or later. Not everybody needs ATEX. That's kind of a very specialized deal.
I don't know if anybody else that has it available that I've seen, except maybe some of the very high-end fan companies that that go into those Div 1 or Div 2 applications.
Yeah, and there's a price to pay for that. I mean, just like with anything on the higher rating that you want, unfortunately, the more it costs because it's harder to do. And that's kind of what we have had. Many of our fans will actually pass the explosion rating from UL. We have customers taken our reverse impellers, and we didn't want to go to testing with them. They took them to UL. We gave them all the specs they needed, and they got them explosion rated. So that our blowers are actually for a specific customer. They've gone and got them all explosion rated. So it can be done if somebody has the want to. It could be expounded, quite a bit. I'm not sure which rating they got. All I knew was that all they would tell me is that they got their UL explosion rating. So I'm not sure if it was a full ATEX or not. I kind of doubt it. But they build heat. That customer happens to build heat exchangers, which heat exchangers can be almost anywhere. But they buy a lot of blowers. But there's really nothing in there that should cause a spark on these things. So we should be good to go.
All right, so I think that wraps up the presentation and going to the questions and answers. We have 2 questions so far, but if there's any attendees that have a question, now would be the time to type it into chat. So we'll handle these first 2 questions. So one of these came in when we were talking about explosive environments, and that question is how does ATEX relate to the Class 1 Div 1 or Class 1 Div 2 specifications that we commonly see in explosive environments?
David, I do not know the answer to that question.
We're basically category 2 Div 2, so we're for some gases and dust only. So we don't meet the extreme, but on the certification that we have on the line, it gives you the full UL rating on there because it's a UL document actually that shows it. But for the extreme of the Div 1, Class 1 Div 1, we can't meet that spec. But Class 1 Div 2 basically is our starting point. But you can see the category spec on the website of what we need up to.
Okay, and so for people out there
that you included that in your handouts, those certificates, if anybody wanted to click on those.
Yeah, there are for the attendees. There are handouts that you can download from the GoToWebinar box, and the ATEX one is one of the handouts there. So feel free to download those. So for those in the audience that aren't familiar with Class 1 Div 1 and Class 1 Div 2, Div 2 means that that explosive gases should not be present, but could in a unusual circumstance be present. Class 1 Div 1 means that they are likely to be present. So So a big difference in how you handle sparking issues. And where it sounds like we're class 1 div 2 is the more accurate definition of what Orion does.
Yeah, we went with the ATEX certification for that. So I believe it pretty much amounts to exactly the same thing, but it's just the ATEX certification for that.
All right, and the other question that had arrived was earlier in the presentation, and it says basically, I saw an Orion presentation earlier this year, and it was mentioned that exhaust grills could be oversized compared to the fan in order to have better airflow. Is that true, and could you elaborate on that?
Yeah, I always tell everybody, if I have an engineer that has room, if you can make your exhaust 2x the size of your fan, you'll be much better off. The fan will be as efficient as it can be at that point. Anything less than that, you're losing some efficiency on the fan. People have a hard time making a big hole in the side of their box. But yes, 2x is pretty much the rule of thumb I go with on that. It's kind of like using one times the diameter of the fan for something in front of the fan. It's more rule of thumb. Will they work with less than that? Absolutely. Do you buy anything by doing more than that? Limited return on investment for making the hole bigger than 2x.
Okay, yeah. And we have got no more questions in since we started the Q&A session. So I think people have had time to ask. So I think we're going to wrap up the webinar at this point. Any further comments from you two?
No, Jim, thank you very much for hosting us on this. I hope people got some information. If they have any other questions, they can always feel free to call you or call David or myself, and we will answer any and all questions to the best of our ability.
Right. I think you said, Jim, you're recording this too, so this could be available later as well.
This has been recorded, and everybody who is registered to attend will receive a link to the recording, and I'll send to you two as well. So, but if you attended or if you pre-registered, you will get a link to the recorded webinar.
Okay. Thanks very much.
Thanks everyone, and have a great day.
Thanks everyone.
Bye.